Hey, Didactor here with you again for another great calculus video. Here we are dealing with the evaluating a definite integral and dealing with the fundamental theorem of calculus. So we have gone through derivatives before where there were indefinite integrals. We added a plus c. We did some other things there. Now we're going to get into is what if we have an area that we want to evaluate and we're given an upper bound and a lower bound. So when we look at evaluating an integral, some of the properties that we need to think about are we have an integrand and we are given a and b. Now, when you look at a, I'll bring this over here a minute. Excuse me. This is your lower bound. Lower bound. Right? That's from what the low x value is all the way up to the upper bound. Upper bound. And so those are your boundaries. That's the x values. You have a low x value like 2 up to 5 maybe. So a higher, just like x sub 1, x sub 2 when you go in numerical order, low to high. Low to high. Okay, so we have an upper bound and we have a lower bound. We're taking the integral, the antiderivative of f of x dx. When we do that, we get capital F of b minus capital F of a on the interval from a to b. And that f, that capital F now, is the antiderivative of f of x. So that's what we're looking at. So we're looking at this f of b minus f of b, f of a. What happens when I put an x value, the upper x value, into the antiderivative of the function and subtract that by the lower bound? I'll get that value. Okay, now that's evaluating. So another property of evaluating is if I have from a to b of f of x dx, that will also equal from b to a. So if I want to go from a to b, I can. But if I want to go b to a, now what I do is I take the negation of that and I work backwards. Okay? So of f of x dx. So that's just another property that we want to have. So fundamental theorem of calculus, right here it is. Let's see it in motion. Here we go. Example number 1. Example number 1, we have the integral from 1 to 2 of x squared minus 3 dx. What do? Well, we take the antiderivative, 2, and then we add 1, right? The power rule. We add 1, and then we divide that also by 2 plus 1, minus 3. Well, there's no x, but now we have to substitute an x in. Okay, so put that x in there. We also change the integrand from this style, right? That is the function. That's directions, if you will. Hey, take the antiderivative of this with respect to x. And now we change it, just notation here. We change it from 1 to 2. We draw a straight line, and that means that we're done with the antiderivative part, and we're ready to actually substitute numbers in. So here's our values again, x cubed over 3 minus 3x from 1 to 2. All right, well, let's see what happens when we put the values in. We get 2, which is x, right? We substitute 2 in. 2 cubed over 3 minus 3 times 2 minus, because we get that right from the function there, minus 1, right? There's our lower bound. Plug in the lower bounds. 1 for x cubed over 3 minus 3 times 1. This is 8/3 minus 6 minus 1/3 minus 3. And when we subtract that out, you get a value of negative 2/3. All right. So that is example number 1. Here's example number 2. Let's say we have something where maybe we have an absolute value of something. Now recall, because the absolute value function goes off in a V formation, we have to look at where are those x values, what are they doing, and do we have a negative side and a positive side. So what's happening with those x values and subsequent y values. So what we have to do is we have to find, well, if we set 2x minus 1 equal to 0, we'll get 1/2. That's where the divider comes in, right? That's where the v comes in. That's the evaluation of that vertex, okay, at x equals 1/2. So now, I have a negative case and I have a positive case. The negative case is the negation of the 2x minus 1. Well, where does that negative happen? That is going to be on the left side. That'll be x's that are less than 1/2. Then I have, well, where's the 2x minus 1 in the positive sense? Well, that is for x's equal to 1/2 or greater. Okay, so what we want to do is we have two areas to evaluate, one to the left and one to the right. And in essence, what we'd see is, if we were going to draw this out, if I can just quickly make a sketch, we would get here, and then our function would be at, coming this way, and we'd see this, and this would be at 1/2, right? So we have a V shaped, and then what we need to do is we need to evaluate. Now we've got this side of an area and that side to 0, right? So that's what we're trying to do by splitting it up into two areas. All right, so two areas to evaluate. We have 0 to 1/2 of the negative side, right? So negative 2x minus 1 dx, plus we're going to add to that the other side of from 1/2 to 2 of 2x minus 1. So we have to integrate, find the antiderivative. X is x squared over 2. The 2's would cancel. Okay, the 2's would cancel there. Plus, now this is plus because if I distribute this negative, that gets that negative there. And then if I also distribute the negative there, it gives me a positive there. So then I'm going to evaluate that from 1/2 to 0, or 0 to 1/2, I should say. Then we're going to add that to this antiderivative, which is x squared minus x. Again, if I add 1 to this x here and then divide by that, the 2's would cancel, giving me just x squared minus x. And that's going to be evaluated from 1/2 to 2. Well, in this case, 1/2 squared is 1/4. Bring the negative along because the negative is outside. Plus 1/2. And then 0 would just be 0, so I left that out. We could actually say that that's plus 0 in here, but that's okay. We don't need that necessarily. And then plus the quantity, right? Because now I do have two things that I've got to subtract. So I have x squared is 4 minus, as 2 is x, that's 2 minus 2, minus 1/2 squared is 1/4, minus 1/2. Okay, so there's our 1/2. And then we simplify that. So negative 1/4 plus 1/2 is positive 1/4. Right? And then plus, this will be 4 minus 2, which is 2. Minus a minus 1/4 will give me a 9/4, right? Because 2 plus 1/4, so that's 4, be 2 1/4. 4 times 2 is 8. 8 plus 1 is 9, so that's where we get the 9/4. 1/4 plus 9/4 is 10/4, and so our final answer in reduced form is 5/2. All right, that is a little bit about how to find a definite integral with an absolute value situation, where we have a graph that's a little different, interesting, and we also have just a regular x squared minus 3 function. This has been evaluating a definite integral and the fundamental theorem of calculus. All right, thanks again. Hope you have a great day. Peace out. D. Dykstra out.